Hi guys, welcome to this introduction video on KiCad. So I decided to make a very simple design. It's only based on through-hole parts, so it should be very easy to solder if you decide to make this project for yourself. And it's based on the LM555 timer, and you can adjust the flash rate for this LED here by adjusting the trimmer over here. And you can apply power here on this screw terminal. So let's have a look on the PCB design itself. First we have to make a schematic of the design, so we have everything based on the integrated circuit here, a few passive parts and the LED, some mounting holes, and then the power connector over here. And we of course have the PCB design itself. So it's a simple 2-layer board, mounting holes here, and the size here is 40 by 30 millimeters. So let's get started doing the design, and I hope you will learn something from doing this together with me here. So here we are in KiCad, and as you see I already started a new design. So it's called LM555 testboard. And if you want to create a new project, you just go here to File and then New Project, and then you decide what name you want to give the project. And you see it automatically creates 2 files. One is for the PCB and the second one is for the schematic. And over here you have other possibilities. You can create new symbols, or you can create a new footprint, Gerber viewer, and different other nice tools. But let's concentrate first here on doing the schematic for our LM555 testboard. So here we have a blank canvas, and the first thing that I normally do is to fill in the sheet informations. You go to File and then to Page Settings. And we want to give it a date. You just click here, then you'll take the actual date. The revision is 1.0. Title, that's LM555 testboard. Company, that's my YouTube channel, made by Morten. And then you just click OK here, and then you see the information has been filled in here. So now we can start adding some different parts, and the star of the show is of course the LM555. So we go up here to Place and Place Symbols, and you see the shortcut is press A. So let's find a symbol for the LM555. And we see different options here. And this is the one we want to use. This is in the through-hole version. And we just place it here. And we would like to give it some power. So we say place and place power symbols, and the shortcut for that is P. And of course we would like to have one called plus 5 volts. And we just place it around here. And I would normally like the string to be closer there. And we can place a wire here. Just click on the mouse and then you have a wire. And we would like to have ground as well. P for power. And we would like to have a ground symbol. And we would place it down here somewhere. Like that. We can place it in the middle here. So one of the important things is that we would like to have an LED connected through a resistor. And we will find a resistor and we press A for place part. And then we would like a resistor R underscore small. I like that symbol for a resistor. And we press A for place part again, and we would like an LED. So we just take this standard LED here, and then we press R for rotate, like that, and then we can place a wire in between here. W for wire, like that, and then of course we need a ground symbol, and then we just click or highlight the what we want, and then we press Ctrl D for duplicate, and then we just got a copy of the things that we highlighted. And we want this resistor to be a 1K resistor, and we want the LED to be green, like that. So the reset line here is connected to 5 volts directly, so we can just route that one. Like that. And then the 5 volts, we would like to decouple that through a 100 nano farad capacitor. Press W for wire, approximately there, and then we say we would like to place a part, press A, and then we want to place a capacitor, we call that C_small, and that's the symbol for a simple capacitor, and we would like to have it a bit further out here, and that should be 100 nano. And we would also like a ground symbol for that one. I just need to bring that up a bit, like that, and then we highlight that, just click on it, Ctrl D, and then you can just place it on the part directly, and then you can highlight it and then just press down the mouse and then move the part a bit away, and then you can align it that way, like that. And then on the CV pin there we need a 10 nano farad capacitor, and we can simply just highlight this, Ctrl D, and then we would like that to be a 10 nano, like so. And then we have the TR pin here that needs to be connected down here, and we would like to go that into the THR pin, like that. And we need a trimmer and a few more resistors, so we will just press Ctrl D on the 1K resistor here, and we'll place it approximately here, and we need to add 5 volts to that one. W for wire, and then we need one more resistor of 1 kilo ohm. We need to bring that down a bit, looks better. Ctrl D, and like that. And we would like to move that a bit, so you can just highlight this and then press G, and then you can move it like that. So we need a trimmer, place part, that was A, and let's see what we have. That was wrong. Place symbols, and we would like to have a trimmer, and we have different ones here. I would like this one, and I would like to rotate it, and then you can just mark it here and press the right key on the mouse, and then there is something called transform selection, and then you can mirror it horizontally, and that's the shortcut for that is by pressing X like that. So that fits in nicely. Just need to connect those two, and that should be like a 10 kilo trimmer. And then we have this pin here, that's a no connect, so we can place a no connect flag. It's a small X like that. And over here we need to place a capacitor, and that should be like a electrolytic one. So let's have a look what we can find. So we call that C underscore and then polarized small like that. And we need to connect that to ground as well. Control D. Like that. And the value, that should be 47 micro and 16 volts. Like that. And we can then move up so that they are on the same level. It makes everything look a bit more easy to read and a bit more prettier. Can move this up a bit. And then check if they are aligned a bit further down. Like that. So this is very simple basic schematic. What we need is a power connector. So let's see if we can find one. Place part, and that was A. And then there's a symbol called screw terminal, and we need one with 2 wires. And then when we just have it here and select it, then just right click on the mouse, and then you can also mirror it horizontally or press X. And we would like to have 5 volts. Control D. Sorry. Control D. Like that. And we want a ground symbol. Control D. And then we just connect the 2 power symbols here. So now we are able to connect power to our circuit. And then I would like some mounting holes, 4 mounting holes, and they should be connected to ground. And then we place part, that was shortcut for that was A. And then we just start writing up here in the filter, mounting. And there we see a mounting hole, and there is possibility for connecting a wire to that or a net. Oh, sorry, mounting. That like that. Double click here, and then rotate. And we just need 4 of those. Control D. And then we can just select those 2 and Control D. And then we have 4. And we should connect that to ground. So we have a ground symbol there. Control D. And then we just need to route tracks here. Like that. So now we have a very nice schematic, and we don't have that many parts, and you can see they also that their designators are in a manner here: C1, C2, C3, R1, R2, R3, and D1. So they have okay designator names, but we can also make an annotation of that. So we go to Tools, and then Annotate Schematic. And then we can say, okay, we want the whole schematic to be annotated, and the direction they should be is just like a typewriter, or you can do it in the opposite direction in X and Y position. So we can just try and see what happens if we do this. And then you can see from the top here, R1 is starting here, R1. This is slightly higher, so this is R2, R3. And the capacitors, that's C1, C2, and C3. That's the same as before. But now they have a simple name, and everything is in place. So now we have the schematic done. The next thing that we should do is we would like to assign a footprint to all the parts. So we can do that by going into Tools, and then we can say Edit Symbol Fields. So here we see all the parts, and you see footprints. We need to add some footprints. We saw when we selected the integrated circuit, the LM555 timer, that was already assigned a footprint for that. But let's start and add some footprints to our components here. So the first one is those should be a similar footprints for those two capacitors, but they have different values, so they have a different line. So you can also say, okay, let's see here, R1 to R3, they are 3 1K resistors, but if you want to have different footprints for them, for example, then you can say this group symbols, you can click that one, and then you have them on a separate line here. And also the mounting holes, they have separate ones. And of course you can see here they are excluded. If we generate a bill of materials later on, then we can see that the mounting holes, they are not being included in the bill of material. So if you have something on the schematic, then you can just, that you don't want to get mounted, then you can just exclude it from the bill of material by setting a check mark in here. So let's start to find a footprint. And we would like to find a capacitor. We can just say we want to collapse all. And then we go to capacitor, and we want to have a through-hole one. You can also find capacitors, or we can just remove that C here. And then say collapse all. And up here we see capacitors, through-hole ones, and there's SMD ones. So many of the libraries, there are SMD parts, and through-hole parts, they are being separated. So capacitors, and we want through-hole ones, and we want to have these disc ones, and that should be like a 7mm, and we would like the width to be 2.5mm, and the distance between the pins should be 5mm. So let's check out that one. And you can just click on it here, highlight it, and then Control C and Control V. And you do that V here, Control V here, then you just copy that line. We would like a similar footprint for that one. So we have the electrolytic capacitor, and then we need another library. No, we need the same library, and that should be a radial and the diameter should be like 5 millimeters. And the distance between the pins should be 2.5 millimeters. I think this should be this one. Then we have our LED. So we could also just here in the filter just write LED. Then we get all parts with LED inside the footprint. And this is just the standard one, 3 millimeter one. Say OK. And the mounting holes. So we can just start writing mounting. And that is a 3.2 millimeter one. So the hole inside is 3 millimeter, but if you want to have a screw inserted, you need a bit more. So 3.2 millimeter is the correct one. And the screw terminal. Let's have a look on those. We can say collapse all. And then there are terminal blocks. Let's see, maybe Phoenix, they have one that we can use. There's a series called PT 1.5, and this is with a pin spacing of 3.5 millimeters and 2 pins. Yeah, let's try that one. And then we have some resistors. So let's go and find resistor. And you see there are different resistors here, SMD through hole ones. So we take the through hole, and we would like to have an axial one, and the length that should be 6.3 millimeters. Yes, that's correct. And the diameter 2.5, yeah, and then we want to have the total length 10.16 millimeters. So that will be that one right now. Then we have a trimmer, and we saw that there are through hole ones here, and I like the ones from Burns and the series 3386P. So this is this one. All right. So now we have included all the footprints. Of course, if you want some other informations to be inserted, let's say that you want to have the Mauser part numbers, for example, then you can also add that, and you just do that by adding it over here. And let's just write Mauser. And then you see a row over here with Mauser stuff. You can just fill in the informations about the part numbers here. And then when you generate the bill of material, then you have all those informations in here. And if you want prices and so on, you can make different columns here with different data. But you can apply and save to the schematic and continue. Like that. Now we saved it. You can also export this if you want. Just go down here and then say export. And now we wrote a bill of material to the file LM555 testport CSV. So it's a comma separated file with those informations inside. Okay. And okay. And if you want, you can also generate a PDF file of your circuit here. So you will go to File and Plot. And you can make it in different formats over here. And the PDF is the default one. And the output directory is just the default library or the directory that we are working in right now. So we can just say plot current page. And it already generated the file. So let's have a look on it. We can say close here. And then we can go out here. And we see that the CSV file that we generated, the comma separated one, is here, and then the PDF file is here. You can just double click on that one and it opens our design here as a PDF. Alright, so now we should be ready to go to the PCB editor, and we can do that from the schematic editor. So when we in here, we just go up here to tools, and then we can say update the PCB from schematic. So we have all the necessary information has been entered into the schematic, all the footprints has been enabled, and we have all the parts the way that they are connected. So now we are able to open the PCB editor. So this video is sponsored by PCBWay, who offer a wide range of manufacturing services for your projects, including PCBs from very low cost prototype boards to more advanced PCBs, all the way up to 60 layers, and also with specialist FR4 materials. You can also get your rigid flex PCBs made if you want to make something a little bit more interesting. They also offer a wide range of PCB assembly options. That means getting your PCBs assembled with components on both sides of the board, whether they be surface mount or through-hole parts. PCBWay also offers some mechanical services such as CNC machining, sheet metal fabrication, 3D printing, and also when you're making something with a little bit higher volume, you can also get some injection molding done here. So don't forget to visit PCBWay.com. So we just press update PCB from schematic. And we will just see some information about the different parts that has been added to the design. Then we can say update PCB. And we see that there are 0 warnings and 0 errors. And here we see all the parts. They are here. All the ones that we defined in the schematic has been put in here with the footprints. And we see the rest nets here connecting the different parts. So the first thing you need to do when you have a design like this is to define the outline of the board. And we can do that by selecting this layer here. We can see the different layers on the PCB that we have, and we are just working on a simple 2-layer PCB, so we need the front and bottom layers. Those are these two, and then for the outline of the board we need to go to this layer called edge cuts. So if you press out here, then we have that as our selected net or layer, and you can also see that this is up here. You can also use this drop down, but this gives a better overview, I think. So let's place a rectangle here, and I have it on a 1mm grid. So I can just say I want the PCB to be 40 by 30 millimeters, like that. And then we have the outline of the board. And we can just round the corners of the board. So you go to shape modifications, fillet lines, and we want it to be 3 millimeters, like that. And then we have nice rounded corners. And then we can take the mounting holes and we just go out here. If you hover about the part, press M for move. Sorry, you need to select it and then press M for move. Then we can just move them to the different corners here. Move, like that. Move. And move. And the other parts we can start moving those as well. And the power connector. And rotate that a bit. It's approximately the middle, this. Then we can take those parts away. The trimmer. And we can just hold control down and then highlight the parts that you want to select. And then we can move those away like that. And we want our integrated circuit heater in the middle. Approximately here. You can take the trimmer, move it over here. Like that. Then we want the LED to be placed down here. Yeah, sometimes you can see it's a bit confusing to have all those different labels here. We can remove those, and they are in the fabrication layer, so you can hide them here by clicking here. So it gives a better overview of how the parts are connected. So we can see that R2 is the one that are connected to the LED, and we can just rotate the LED. You just highlight and press R for rotate. And then we have two resistors here, and one is connected to 5 volts. So they are connected together here. And this is our 5 volt net, yes. And let's do it like that. We can also select a finer pitch, 0.1 millimeters, like that. And then we have the decoupling capacitor for the 5 volt for the integrated circuit here. So let's place that as close as possible to the 5 volt. Like that. And then we have the capacitor down here connected to pin 5. And we can just rotate that like that. And we can maybe get everything a bit closer over here. And then we have our capacitor. We could make room for it over here maybe. So it should be close to pin number 3. Somewhere like that. I think that's fine. So now we have placed our parts where we think that could be a good idea, where it makes sense. And yeah, let's remove those ones. We don't want the designators for the mounting holes to be visible. We can just delete them. And for the designators, let's have a look on their position. We could move that away up here to for the LED. And we could just rotate this one. Put it on top. J1, just rotate it like that. And then the capacitor. That, and the integrated circuit, could just have it here on the corner. now I think that we are ready to route the board. Could maybe just drag this a bit further away again, like that. Okay, let's see if it makes sense to route the board as it is. So we just press save, then we have a fresh copy or a backup, and I would like the default lines width to be 0.5 millimeters, and we can say file and then board setup, and there's something called net classes, and you see we have a default net class, and the track width is as a default 0.2 millimeters, and I would like that to be 0.5 millimeters, like that. So when I start to route, then the track width will be 0.5 millimeters. So we just can just press route here. Oh, sorry, that was rotate. And we press X in order to route a track. And then we just do it like that. And we can see that the track width is 0.5 millimeters. If you highlight it, then you can see down here where the width is 0.5 millimeters. And we can see here this is the part, this pin 3 is not connected to anything. And for now we just leave the ground pins. We can connect them by making a flood fill to the whole PCB where we connect all the ground pins together, so we don't take care of those right here in the beginning. And you can also see here these mounting holes are connected to ground. And I can see I rotated this wrong way, so we can just move that out a bit up again and move the designator like that. And then we have this wire, press X, and that was a small mistake here. Just press D and then you can move it around like that. And the firewalls, we would like that to be routed up here and up here, so we just go like that, and we can go in between. If there's an error, then you can see this is being green. It means that there's a problem here. And the firewall pin, we can just connect that on a different layer. So now we are on the top layer, and we can go to the bottom layer, and then we can make a track here for the firewalls like that. And we can go to the bottom layer or the top layer, and we can route this track here. Like that. And this is a ground, ground, ground. And we have this track here. So that should go up here. And there. So now I think we have all tracks connected. We only have one connection here on the top layer, oh sorry, on the bottom layer. I think that's fine. And this is also a ground. And we want to make a flood fill on both layers, both on the top layer and the bottom layer. So we go to place. I want to change the grid to 1 millimeter again. It makes it much easier. 1 millimeter grid, and then we say place, draw, filled zones, and then we just highlight the area where we want it, and it asks, okay, which layers do we want to do it? We want both the top and bottom layer, and we want to connect it to ground. And we just need the clearance to be 0.2 millimeters and the minimum width 2.2 millimeters. And we can make those 0.3 millimeters and 0.3 millimeters. Like that. Press OK. And then we make the area where we want that fill to be like that. And then if we want to see the result, then we just press B. Then it will fill the whole PCB, both the front and bottom layer. And we can see, we can hide the bottom layer. We can just click here, then we go to the bottom layer. We can then hide the top layer if we want. And there you can see all the ground pins has been connected to the flood fill. You can see that by connecting those wires here. And the LED here is connected to ground, capacitor, and the power connector. Like that. Then you see it has not filled the board completely to the edge. Normally you want to have a bit of clearance to the edge, but we can change that. Right now it's 0.5 millimeters, but we can do that here in the board setup. And then you go to constraints, and we see here that there's one thing called copper to edge clearance, and we want that maybe to be 0.1 millimeter only. And then we press OK, and then we press B to update the board, and then you see it has been narrowed down to 0.1 millimeter instead. So I would like to have some text just explaining what is what here on the connector. So we say place, draw text, and the layer should be the top silk screen, and I would like that to be plus 5 volts. And I want one here just called ground. And I don't want to have it as a bold ground like that, and not bold, just like that. And then we need to move the grid a bit finer. And it's just press M for move when you have selected it. Press M, move. Like that. And let's make it a text down here. Place, draw text. So we call it LM555 test board. Made by Morten. And we see this is too big, and we want it on the silk screen. Let's say 1 millimeter. Like that. And we can also put some different things on the back side of the board. So we can place footprint. There's one from KiCad. So there's a KiCad logo here. And if you want to have that on the other side, now it's on the front silk screen, and if you want to have that on the bottom one, just select it. And then press F for flip, then you go to the opposite side, opposite silk screen. So now this is the bottom silk screen. You can see the color here, and that matches the bottom silk screen here. So now we are on the bottom, and we can just place it down here. That. And I also have a small YouTube logo, and I think that's called YouTube. And we want that on the other side as well. And I want some text, place draw texts. Then we write powered. And that's YouTube channel made by Morten. And of course my sponsor, PCBWay. That, and let's see how that looks. We have some more room, so we can make it a bit bigger, maybe 0.2. That was too much. Some of these things you need to play a bit around with it to find the right sizes. Yeah. The problem is that, you know, this is a through-hole parts board, so it'll destroy some of the silk screen, but I think you get the idea. Press M for move, like that. So I think that we have all the things that we need to make our design. So one thing is pretty handy as well when you do a design like this is to view it in 3D view. So you go to view and 3D viewer, and here you can see the design, how it would look like in reality if everything fits. And you can see here the silk screen on the bottom side, and you can see the pins is coming through. Over here you can enable and disable the through-hole parts and the SMD parts. So like that, then there's no parts on the board. And then you see the silk screen. I can see there's something with C2. I need to put that designator up there. Can just do that right away. So we go to silk screen and press M for move and then R for rotate. And if we place it right there, like that, and then we go to view 3D viewer again, and that looks much better. And we can enable the through-hole parts again. And we see here that the trimmer is not available. I can just show you here on this web page. It's a page called SnapMagic. You can find all sorts of parts there. You can also find the footprints and schematic symbols, and sometimes you also have a 3D model available. And I found a 3D model here for the trimmer, and you can simply just download it from in here when you have registered on their page. So let me find the trimmer, and what you do is you double click here on the part. There's something in here called general. There's some different informations about the part, and there's one called 3D models, and then you just add a new 3D model. Don't want to show the other one. There's apparently no model here in this directory, so we can just add our own. So I have one here called 3386p, and we would like to open that. So now we can see it's not placed correctly here on the PCB. Then we can just rotate it a bit, and maybe that's the Z direction, like that. And then you see it's on the right side, but we need to move it slightly in the Y direction. Yes, 2.5 millimeters. The height is actually fine, but we can also adjust the height here, but it seems to be fine. And we press OK, and let's see again. And there we have the 3D part. Like that. One thing that I forgot is just to write a few informations about how this works with the trimmer and the LED blink rate. So we can just go back to the schematic. I would like to add a small note about that. So we can just place some text. And I would like to add a LED blink rate. That should be 1.3 to 10.2 Hertz. And apparently I had my caps lock down. LED blink rate 1.3 to 10.2 Hertz. And then we have the duty cycle. And that should be 52.2 to 66.7%. And we can just make that a bit bigger than the other things, like that, and like that. So now we also have that information. So when you move the trimmer, then you can have the frequency of the blink from 1.3 to 10.2 times per second. And save. And we can have a look on the other side again. Perfect. So now we have our design. We can just verify that we have everything connected. So let's go into the PCB design again here. So let's say if we forgot to route a track or anything, then we would like the system to check that we have done everything correct. So we go into Tool to inspect design rule checker. And then we can run a design rule check. And then we see we don't have any errors. We have 7 warnings, and they are all being concerned about that we have some silk screens that has been clipped, but that's natural because we have through-hole parts and we are close to the border with some of the stuff. But it's just warnings, so yeah, we should either remove these warnings or just say, okay, this is fine. But I'm not worried about this, so I'm happy. Let's see if we then select this track, for example, and if I press delete, then you see it's not connected, it's not routed. And if we do a inspection again and make a design rule check, and then this is the old one, and then say run device rule check, then we get one error, and then we can see, I would like to show only the errors. Then we can click away the warnings, and there should be like one unconnected. I need to check, of course, the errors, and then we see there's a track missing here between the 2 parts, between R1 and R3, and this is the wire here. So let's try and route that again, like that, and then save, and then we can say inspect, design rule check, and then run design rule check, and then we see 0 errors and 7 warnings. So this is the way that you can verify that you have done everything correctly. So we are happy about our design. There's one final thing that we should do is to make the fabrication output for the manufacturer. If you want to send the design to PCBWay, for example, then you should make a Gerber file or Gerber files, and the way you do that is to go to File, and then you go to Fabrication Outputs, and then to this one called Gerbers. And in here you can this is just a simple 2-layer board, so you see the front copper layer and the bottom copper layer is already selected, and the paste masks and the silk screen and the solder mask, they are all being selected here. This is standard one, and the outline of the board. So it's just say plot, but we would like to have it in a directory for itself, or else it'll be mixed together with all the other design files. So we just create a directory called Gerbers, we should just make it here. We should of course make it first, new folder, like that, and then select it. So we see it's selected down here. Yes, and then we see it. We could also just write it up here, Gerbers and a backslash, and then we say plot. And now it generated all the files. There was no errors or warnings. And then we can say generate the drill files as well. We need those as well, like that. So now we see in our design system here that we have a folder called Gerbers, and there they are all of the needed files for doing the manufacturing. And normally you just go into this folder, zip all the files into one file, and then you can ship off to the manufacturer. So this was just a very brief introduction on how to make your own small design. I really hope that you enjoyed the video and you are now able to make some PCBs for yourself. So please enjoy KiCad, and please feel free to add some comments in the video down below, and yeah, see you in the next one. Bye.